Last time we were using this formula right here. So this one always works, but the issue with this one is that it's long. If you don't want to, you don't have to use that. Let me show you. What kind of a function do we have here? What's f of x? Is it a polynomial?
No.
No, it's not, because you have a root x. So this would be a root function. That one's going to take priority because x cannot be negative. Essentially, that's what it is. The question is differentiate the following function. So we want to find f prime of x. That's the goal, f prime of x. Let me show you using the long way because it's important to know it this way as well. This way is bulletproof. It always works. The other way, it doesn't always work. So this is the formula to find the derivative of any function. So if f of x is this, what's f of x plus h? We're given this function, f of x, we want to find f of x plus h. You know how to do this?
You just replace x with x plus h.
Yeah, that's it. So this becomes 3x plus h whole squared minus 5 square root of x plus. So there's two things here. So let me just do it like this. So f of x plus h is going to be this and this replaced as x plus h's minus. So this green bit is just this. So minus, now we got to do f of x, the original function. Now the original function is 3x squared minus 5 root x. Like that, and you have an h in the denominator. I'm going to open both of these brackets. And again, remember, a plus b whole squared is a squared plus 2ab plus b squared. So x plus h whole squared would be x squared plus 2xh plus h squared. So that's what you would get if you were to open this bracket. And we're going to multiply that with a 3, which will give us 3x squared plus 6xh plus 3h squared. Can we open this root? Would that be root 5x plus root 5h? Can we do that? So can we distribute this 5 inside is the question. And the answer is no, you can't. You cannot open a root. You can open brackets, but a root is not a bracket. So that one we can't do anything. Minus 3x squared as well, 3x squared. And that minus at the end becomes root 5x. Does anything cancel out?
3x squared.
3x squared is the only thing that cancels out, which is a problem. All right. Now what are we gonna do? Because the goal is to cancel out the h, right?
Mm-hmm.
There's a root, we can't really cancel out any of the h's. We could take out this h and this h, but we are not allowed to cancel that with the denominator, not yet. What we're gonna do is this. We're gonna call this limit as h approaches 0. And I'm gonna distribute this numerator because that's the only way to cancel out the h. I'm gonna do this. Plus negative 5 root x plus h plus 5 root x all over h. Am I allowed to do this?
Yes.
Yes. So over here, we can pull out an h. So this would be like this, because the limit applies to everything inside. So here I can pull out an h. I'd be left with 6x plus 3h. I can cancel out this and this. So this thing gives me 6x plus 3h. What about the other one? How do we go about canceling the h's in something like this? If you want, I'm going to rewrite it in this way. Maybe you'll see it. Whenever there's a root, I'm just going to write this here and write this here so that it's in the form of a minus b. Maybe we can see it then. How do we get rid of roots? We need to multiply it by something. The conjugate. With square roots, you always want to multiply by the conjugates in the form of a minus b, a plus b. So right now this is a minus b. What do we multiply this with? What's the conjugate of the numerator? It'll be in this form, a plus b form.
So it's the same thing, but you add instead.
Yeah, it's the exact same thing. You add it instead. And that's the conjugate. And that's an approach we use anytime we have roots. We want to cancel out roots. So it's going to be like this, 5x plus h. So we're multiplying that in the numerator. You have to do the exact same thing in the denominator. Because essentially what we're doing is we're just multiplying by a 1 because the numerator and the denominator is the same. Like that. And now let's look into this. H times that is just H times that. There's no really cleaning up anything here. So 5 root x plus 5 root x plus h. Now let's look at the numerator. We have a minus b, a plus b. That's a difference of squares. That's a squared minus b squared. What would be a squared here? If this is a, what's a squared? A is 5 root x. What's a squared?
5 root x squared.
So that'll be 5 root x squared. That will be 25x. 5 squared is a 25. Root x squared is a root x. So a squared here would be 25x. What about b squared? This is our b. So if we square this, what do we get? So we would get 5 root x plus h whole squared. 5 squared is 25. Root x plus h squared is what?
X plus h.
Yeah, so it's 25 times x plus h. So it's 25x plus 25h. But here we have to be careful because there's a negative in the front. So there's a negative, which means we will end up getting negative 25x. We just multiplied this term with a minus 1, minus 25h. There we go, like that. Can we cancel out the 25x's?
Yes.
Yes. Can we cancel out the h in the numerator and the h in the denominator? This and this?
Yeah.
Yes. So now all our h's in the denominator are gone. Once the h's disappear, you're allowed to plug 0 back in for any remaining h's. So 3 times 0, 0. 5x plus 0, 0. And that's it. So our derivative, our final answer, is going to be 6x minus 25 all over 5x plus 5 root x is going to be, it's like 5a plus 5a, essentially. It's 10a or 10 root x. And there we go. That's the final answer. So a little bit tricky. You need to know how to use this formula first and also how to deal with roots. The algebra isn't too bad if you know, this is grade 10 level algebra because a minus b, a plus b, difference of squares. So this is the long way of doing it. There is an easier way of doing it, which is what we're going to do moving forward. But it's important for you to know how to do it this way as well. Now we're going to use the shortcut way. If you have in this form, k times x to the power of n, if this is your f of x, your derivative, which is the slope of the equation of the tangent, this is your m value, the slope of the tangent line. Your derivative, the equation is going to be, you bring the n down, and you take 1 away from the n. And if there's an x value given, you would plug that in here, and that will give you the slope. So that's our shortcut. What's the derivative of 3x squared?
6x.
So that one's easy, right? 5 root x is not as obvious. 5 root x, what we're going to do is we're going to rewrite this as 5 times x to the power of 1 over 2. Now it should be obvious. What's the derivative of this? It's the same rule. You bring the exponent down and take 1 away from the exponent. So 1 over 2 comes down. Okay, look at this. Minus the n comes down. So 1 over 2 comes down. 1 over 2 times 5 times your x. What's the new power of x? You take 1 away from a half. Yeah? 1 over 2 minus 1 is negative 1 over 2. So this is 6x minus 5 over 2 root x. And I think we had something like this before as the final answer as well. So there you go. That's the shortcut. Cool?
Mm-hmm.
Do you understand how this became this?
Mm-hmm.
So that's how you want to deal with roots. Anything you can write in this form. Again, it doesn't have to be a polynomial. Anything you're able to write in this form, you can use the shortcut method. Same thing's going to apply to the next question, but the next question is slightly trickier. So here, again, it's the exact same thing. You have k times x to the power of n times k times x, n minus 1 is the derivative. If this is y prime, which means the derivative. What's y prime here? And here you're going to treat this entire thing as x. So what would it be? You bring the exponent down, so 2.
Mm-hmm.
The constant in front is 1, so 2 times 1 is 1, so that k is irrelevant. Your x, your original thing, everything, what's the new power?
1.
1. So now you'd expect this to be the final answer, but let me show you the difference between this question and the last question. Last question, we only had x's, so it was pretty simple. If you did this step, you're good. You have an x inside, which is the bare minimum. But here we don't have an x anymore. We have a 3x plus 2. So if you have something else except an x as your inside function, as your inner function, then you need to do one more thing. After you do this, you need to multiply this by the derivative of the bracket. What's the derivative of 3x plus 2? If this is y, what's y prime? So you
What
can use
happens to the 2?
the 2 has an x 0 attached to it. You can look at it that way. So 0 times 2 is a 0. The derivative of 2 is 0. The derivative of any constant is a 0.
It's just 3.
It's just 3, yeah. So you have to multiply this by a 3. So your final answer is 6, 3x plus 2, which is 18x plus 12. That would be the final answer, okay?
Mm-hmm.
There's another way to do this question. If you don't want to use this thing that we multiplied it by, this very important concept, this is called the chain rule. And most of the times you have to apply this. But polynomial is an easy function. So if you don't want to use the chain rule, there's a better way of doing this. Another way of doing this is that you first open the brackets. So right now it's just y. We don't take the derivatives. This is a plus b whole squared. That is a squared plus 2ab plus b squared. So what's a squared here? If a is 3x, what's a squared?
3x squared.
9x squared. What is 2ab? So it's 2 times 3x. So let me just show you what I'm doing. So a squared is 3x squared. 2ab is 2 times a 3x times b 2 plus b squared, which is 2 squared like that. So 3x squared is 9x. 2 times 2, 4 times 3x is 12x. What's b squared?
It's 4.
That's 4. Now this is our y, okay? This is just the original function. Now let's take the derivative. What would be the derivative of this?
18x.
18x? What about 12x? What does that become?
12.
12, there we go. And 4 becomes nada, nothing, gone. That is the same thing as this. So you can always open the brackets if you want, but I would suggest we're going to focus on this method because this is way more powerful. And sometimes, let's say you have something like sine of 3x plus 2, you can't open this bracket. So the later method that we use would not apply to this question, okay? So that's the idea of chain rule. If you have a function within a function, if the inner bit is anything but an x, you have to use the chain rule. Not this question though, this we just have a bunch of x's. Looks like a tricky question, but it's actually very simple. So what is this question asking us? We have a negative cubic function. Remember, cubic function, the positive one starts in 3, ends in 1. A negative one is the opposite. It's a reflection on the x-axis. So it start here and go here, okay? We don't know where the x-intercept is, not that important. We know where the y-intercept is, it's at -2. So a rough sketch of this would probably look like this. Determine the equation of the tangent at x equals 1. So x equals 1, let's say this is 1. So this is our y value. We don't know what it is yet. But what we're trying to find is this equation of this tangent line that's perpendicular to that point. So the question is, what is mx plus b? Specifically, what is m and what is b? If we have our m, if we have our b, then we have the answer. Okay, so how would we find m? M is the slope of that line. I can give you a formula. M, the slope, will always be f prime at that x value. So what we do is we first find f prime of x, and whatever equation that we get, we plug in the x value, and that'll give us the slope. So if this is f of x, what's f prime of x? What's the derivative? What's the derivative?
-3x squared
Yeah? What are the next term?
plus 6x.
Plus 6x, perfect. 2 disappears. What if there was a pi? What's the derivative of pi? Or e? Or sine 20? All of these are constants, right?
So it's 0.
It's 0. So just keep this. Sometimes they will trick you like this. The derivative of pi is a 0, but the derivative of pi x is pi, because this is the same thing as 3x becoming 3. So anyways, -3x squared plus 6x is the derivative function. We just have to plug in 1 in there now. F prime of 1, which is -3 times 1 plus 6 times 1. It's just like this. Our slope is 3. There we go. Our slope is 3. So we have our m value. M value is 3. Now, how do we find our b value? We just need to know any one point on this curve. So right now we have y equals 3x plus b. This is our line. We need to find the b value. To find the b value, we know our x value. Our x value is 1. If we know our y value when x is 1, we should be able to solve for this b. So what we do here is we find the y value when x is 1, which in this case is f of 1. Notice the difference. F prime of 1 gave us the m value. F of 1 will give us this y value that we need. This y value is shared, this x and y value, this coordinate, 1 comma whatever this y value, both this line and this curve share that one point, which is right here. This point is shared, okay? So if we find the y value from the green curve, we can plug it into this blue curve to find the b value. So what you do now is you find f of 1, which is going to be -1 plus 3 minus 2. Just plug 1 in there. 3 minus 3 is 0. So our y value is 0. So it's going to go through the origin, basically. Now for the final step, y is 0 when x is 1 plus b. Therefore, b is -3. Now we have both our constants, so our final answer for this is going to be slope is 3, y-intercept is -3 for this blue line, the tangent line. And that's it for this question. So just know the difference between f prime of 1, that will always give you the slope of the tangent line, and f of 1 will give you the y value, which is shared by the tangent line as well as the original curve. You can use this point to find the unknown b value. All right, the next question. Determine points on the graph. It's the same question, but now there's a follow-up. Right here is the next question. Determine points on this same graph where the tangents are horizontal. What does that mean? Horizontal tangents. Means the slope is 0. Yep. Look at the green curve here. Where do you think the slope is 0? There's only two possibilities. One is right here. Horizontal tangent means this, where m is 0. Usually happens, you can just use this at turning points. At any turning point, the slope is always 0. So right there, we need to find this x value. Right here, we need to find this x value. So that's our question. We need to find your x1 here, the first x value, it's going to be negative. And we need to find this one, the second x value. So how do we find those? Again, it's very simple. We already have the answer somewhere here. Actually, we don't because I erased it. All you have to do for that, okay? Let me just make some room. To find the x values where the horizontal tangent m is 0, you're trying to find this. You want to set f prime of x equals 0. If you set the derivative function equal to 0, you can find out exactly where those two x values are. So our derivative function here was -3x squared plus 6x. If we set this equal to 0, we can get the two x values where the slope of the tangent line is 0. Because this is the slope of the tangent line, 0. This represents the slope of this. This represents the slope of this. How do we solve this quadratic for x? This is our equation right now. -3x squared plus 6x equals 0. How do you solve this for x? It's a quadratic. Remember how to solve quadratics?
You use man.
So you'd use man for a quadratic trinomial. This is not a trinomial, so man wouldn't apply to this. You want to factor something. See if you can factor something on the left side. Can we pull anything out? That's the goal for any polynomial function. You want it in factored form.
The 3x.
You can pull out a negative 3x. What are you left with if you pull out a negative 3x?
X minus 2.
X minus 2 is good. So what are our 2x intercepts? One of them is at negative 3x equals 0. X minus 2 equals 0. One of them is at x equals 0. So this sketch is not perfect. This should have been here. So a more appropriate sketch would be something like this. So this is actually what the curve looks like now that we know. There's a turning point right here, at 0, and the other one is at 2. So this value is 2, this value is 0, and that's the answer to this question. And x equals 0 and 2, there's a turning point for this negative cubic function. So to find the turning points, set the slope function, or the derivative, equals 0 and solve for x. All right, let's do some complicated ones. Which one should we start with? Let's start with this one. Now notice our inner function is no longer an x. So we're going to use the power rule, but once we're done with it, because our inner function is no longer only an x, you need to multiply it by the derivative of the inner function. So look at this. What's the derivative of this as is? You're just using this rule. Treat this as an x for now. What would be the derivative of this function?
20 times x squared to the power of 3.
X squared to the power of 3. But now you need to multiply this, because the inner function is no longer an x. You need to multiply this with the derivative of the inner function. What's the derivative of x squared?
2x.
2x. So look at this. This is 20x6 times 2x. The answer is 40x7. Instead of using this is called a chain rule. Whenever you're multiplying with something at the end, this is called the chain rule. There's another way of doing this for this question. The other way is to just straight up open that bracket first. Don't worry about the derivatives, just open this bracket. What's x2 to the power of 4? Is it x6 or x? It's x8, okay? x8, you multiply them. Now look at this, what's the derivative of 5x8? Well, 5 times 8 is a 40, x7. And look at this, same thing. Chain rule is better because eventually you run into things that you can't open the bracket straight up. So you won't be able to use this. But this is easier if you can open the brackets, I guess. None of these seem too tricky to me. Here, we'll do one more. So this is what we have right now. I'm going to show you both ways. I want to show you the chain rule way, and we'll show you the open the bracket way if you can. Cannot always open the brackets. So chain rule, we're going to write this as y equals 16x3 to the power of 1 over 2. What's y prime? So now you're going to treat this as an x. What's the derivative of x to the power of 1 over 2?
Um, You bring the 1/2 in the front.
So 1/2, and then we have the inside x bit. What's the new power?
Negative 1/2.
Negative 1/2. What do you multiply this by?
48x to the power of 2.
Yes. So that's one way of doing this. We could potentially clean this up. So this will be 24x squared over the square root of 16x3. So that's 24x squared over 4. Square root of 16 is a 4. Square root of 3x3 is 3/2, like that. 24 over 4 is a 6. x2 over x3/2, you want to use the exponent subtraction rule. So you get this. So your final answer would be 6x 1/3. 4 minus 3/2 is 1/2. Not 1/3, 1/2, which is 6 square root of x. There we go. That's the final answer. So that's using the chain rule. Let's not use the chain rule. Let's use the open bracket method, which is this. This becomes square root of 16 over square root of x3. Square root of 16 is a 4. We haven't done anything yet. This is still y. This is still y. This is x to the power of 3/2. What will be y prime? If this is y, what's y prime?
4 times 3/2.
Yeah, 4 times 3/2. And what's the power of x?
1/2.
Yes. Look at this. 2 goes into 4 twice. 2 times 3 is a 6. X to the 1/2 is 6 root x. And that's what we had here as well. This is easier if you can open the brackets, right? It's definitely easier. All right, we're going to move away from this and we're going to talk about the product rule. This is also something that we have done in the past, but we're going to take this all the way to the end. Now notice here, you have something multiplied by something. You have two different functions being multiplied to one another. We haven't really seen this. Last time we had something like this, it's just one function, even though there's a root. It's just one function by itself. But now here we have a quadratic on the left, and we have a quintic. X power 5 is quintic on the right. So how do we do this question? There's two ways. This one, can we open the brackets? Yes or no? We can just FOIL this, right? If we do this with this, you'll get x7 plus 2x2 minus 3x6 minus 6x. That's what you get. This is still h of x. And then you find the derivative, which will be 7x6 plus 4x minus 18x5 minus 6. There we go. That's the answer. Now this is because we can open this bracket. But what if they put a 3 here and they put an 8 here? Now opening that bracket is theoretically possible, but there's going to be 25, 26 terms. It's pointless trying to open these brackets. So now what do we do? So we're not going to use the opening bracket method because again, this is a first question. It's obviously easy, but later on you'll see that opening brackets is not going to be possible, or it's not going to be practical. So now what do? So if there's two things being multiplied, we call this f, we call this g. And the derivative of h of x is this. It's f prime times g plus f times g prime. This is called the product rule, when you have two different functions being multiplied to one another. And this is easier. Rather than having to open the brackets, this one will be easier most of the time. What's f prime? If f is x squared minus 3x, what's f prime? What's the derivative of x squared minus 3x?
2x minus 3.
2x minus 3. So that's just f prime. And then you multiply with f prime g, which is by itself. You don't need to change anything like that. So this is f prime, this is g. And then we go plus f by itself. F by itself is x squared minus 3x. What's g prime?
5x to the power 4.
Yes. And there we go. That's the final answer. You can just leave it in this form. Usually people just leave it in this form. You can always FOIL it, right? But this is fine as well. So that's the product rule, okay?
Mm-hmm.
So let's look at this one. So this one is a polynomial to the power of 6. Again, you can open this, but there's going to be, what, 8 terms? Probably more than 8, because there's 3 terms inside. It's pointless trying to open this power 6. So do not open that power 6. What we are going to do, though, is there's 2 ways to do this. You can write it in the product rule form. Maybe 3. Look at this. This is your f, this is your g. But here, both your f and g's, you don't no longer have an x inside, so they're no longer linear, just x inside by itself. So when you find the derivative, you need to multiply it by the derivative of the bracket. So actually, for this question, we're not going to use the product rule, we're going to use the chain rule, which is when the inner function is not an x, anything but an x, which says this. If you have f of g of x, so here our big function is x power 6, and our small function g is x squared plus 3x plus 5. G is the inner function, and f is the outer function. So here the outer function is power 6, whereas the inner function is this quadratic. So if you have it in this form, chain rule says if that's your y prime is f power g prime of x times g prime of x. So let me show you what this means. F prime of g of x means the derivative of the bigger picture, of the outer function. So treat this as an x. What's the derivative of this function? What's the derivative of x6?
You just put a 6 in the front.
You just put a 6 in the front, so it'll be 6x squared plus 3x plus 5. So this right now is f prime of g of x. We did not touch g of x. We did not touch the inner function at all. And then we multiply this with the derivative of the inner function. So what do we multiply this with? It'll have two terms. It's a
2x plus 3.
2x plus 3. There we go. And that's chain rule. There's a power 5 here. And this is the chain rule. When you have an inner function and an outer function, that's what we would use. Okay? But again, it doesn't have to be two functions. It can be a combination of three functions. Let's look at this. Sine x squared plus 3 to the power of 5. Now you'll notice here we have three functions. On the very outside, we have x power 5. This is the outer level. And when we go one level deeper, we have sine of x. This is a second level. Once we go one level deep, we have a quadratic x squared plus 3. So now we have three different functions. But nothing really changes. So the derivative of this, if this is y, look at this, y prime. You always start on the outside and you work your way inside. So we have a power 5 function. We're going to bring the 5 all the way to the front. We're not going to touch anything on the inside. And that 5 becomes a 4. Okay? And now we need to multiply this with the derivative of the inner function. But inside we have two different functions. So again, we work on the outside and we go in. On the outside, we have sine of x squared plus 3. We first need to take the derivative of sine of x squared plus 3. Sine becomes cosine. We haven't talked about this, but the derivative of sine is cosine straight up. So sine becomes cosine. You don't have to worry about powers or nothing like that. So that's the derivative of sine. So we've dealt with this. This is right here. We dealt with the sine x, the derivative of that is right here. But now on the last step, we also need to deal with this. What's the derivative of x squared plus 3?
2x.
2x, there we go. So that's the chain rule applied twice because we have three different functions. Okay? So you need to apply the chain rule multiple times. Let's look at this one. So now, instead of two functions being multiplied, we have a division. You have one function over the other. This is called a rational function. So we need to find the derivative of this rational function. So if you have something multiplied something, this is a case of product rule, which says f prime g plus f g prime. If you have something over the other, as we do in this case, this is called the quotient rule. What's the formula for quotient rule? It's very similar to the product rule, except the plus becomes a minus. So this is your f, this is your g. So the quotient rule says the derivative is f prime times g as it is minus f times g prime is the exact same thing as a product rule, except with a minus sign. And then there's one extra step, all over the original g squared. So that's the formula for the quotient rule, which is what we're going to be using here. So let's look at this. 2x plus 5, that's our f. We need f prime. What's the derivative of 2x plus 5?
It's 2.
It's 2. So that's our f prime. Multiply g as it is. So g is unchanged. Like that. Minus f as it is. So 2x plus 5. What's g prime here? G is 3x minus 1.
It's 3.
It's 3. All over the original g squared. And there we go. Final answer. Not technically the final answer. I guess you could like open these up. 6x minus 2 minus 6x minus 15 all over 3x minus 1 squared. I just open the brackets. 6x and 6x gone. So the final answer is negative 17 over 3x minus 1 squared. So there you go. Most of the time, this will be good enough. Because usually you'll have like a squared or a cubed here, and opening those brackets is pointless. But here we could kind of simplify it into extra steps, but that's the quotient rule. It's very similar to product rule except with a minus, and you want to divide by the denominator squared. Is this making sense?
Yeah.
Okay, here, let's try this. This is what I meant when you can't open the bracket. Or it's pretty much pointless to open the brackets. The question, let me also pull up the question because symbology is something we need to be familiar with. dy over dx, what does that mean? dy over dx means the derivative of y with respect to x. For our purposes, this is y prime, it's f prime of x. All three of these mean the same thing. This gives you the slope or the derivative function. Derivative function is what it gives you. And if you plug in the x value, if you find f prime of -1, once you plug in the x value into your slope function, so x value, we plug it into the slope or the derivative function, then that will give us our m value, the slope itself. So here, part D, the question is asking us, find the slope of the tangent line at x equals -1 for this function. Cool. So step number 1, we're going to find y prime using product rule. And once we have y prime, we're going to plug -1 in there, and that'll give us the final answer. So again, we know this is a product rule because we have f times g. Y prime says product rule becomes f prime g plus f g prime. So why don't you try it? What's f prime here? So f is 2x plus 1 to the power of 5.
So 5 times 2x plus 1 to the power of 4.
So 5 times 2x plus 1 to the power of 4 is good, except we also need to consider the chain rule because now the inner function is no longer an x, it's 2x plus 1. So what's the derivative of the bracket? What's the derivative of 2x plus 1?
2.
2. So we multiply this with a 2. That's a chain rule. So this entire thing is f prime. We multiply this with original g as it is. So times 3x plus 2 to the power of 4. So that's f times g plus f by itself. 2x plus 1 to the power of 5. This is f by itself. What's g prime?
4 times 3x plus 2 times 3.
Yes, perfect. To the power of 3 times 3, like that. And that is our entirety of our slope function. And now I want to find y prime at x equals -1 because this gives me my slope. And that's what the question is. Find the value of dy over dx means find the slope at this x value. So the next step, we're just going to replace all the x's with a 1. So this becomes -2 plus 1 positive 2 times 2 times -3 plus 1 is -1. I'm just plugging -1 in there to the power of 4. -1 to the power of 5 plus 4 times -3 plus 2 is -1 to the power of 3 times 3. So the entire thing is 5 times 2, 10 minus or plus -1. This is -1. That's -4. That's 3. So this is 10 plus 12, 22, final answer. And there we go. So that is an example of a product rule. But again, anytime the inside bit is not an x, which won't be the case 99% of the time, except I guess here. This is the only place where you don't have to worry about x. Every other thing here, you have to use the product rule and the chain rule. What about this one? Is this a product rule question? So anytime you have functions being multiplied, yes, it is, okay?
Mm-hmm.
So now this one, we're gonna do it bit by bit because now there's actually three things in here. So far, we've only seen F and G, but now we have three things in here. So what changes when you have three things? When you have three things, you have to pool the functions together. Either you want to call this F or you want to call this F and this G. You basically have to pull it up. I'm going to go ahead and say this is my F and this is my G. So again, now this is a product rule question. We're going to do one thing at a time. What's F prime? So you'll notice that F by itself has two different functions. So to find F prime, you need to use the product rule. So this is a product rule twice question. You first have to use it on the inner F, and then we have to pool F and G together. So what I mean by that is 2x is your F, and x plus 1 squared is your G. So to find F prime, you have to use a product rule on these two functions using that formula. F is 2x, what's F prime?
2.
2 times G by itself, so x plus 1 cubed, plus F by itself, times G prime, which will be 3 times x plus 1 squared, times the derivative of x plus 1 is 1, so you're multiplying by a 1 for the chain rule. There you go. This entire thing that we just found is F prime, because this was our F. This entire thing is the derivative of F prime. To this, we multiply G as it is. So times x squared plus 2x plus 1 squared. I guess I'll use the same brackets squared. Plus F by itself. So plus 2x plus x plus 1 cubed times, what's G prime? If this is G, what's G prime? Well, you first bring the 2 down. Everything inside stays the same. And take away 1 from the 2. And then for the final step, you multiply it, because the inside function is no longer an x. You multiply it by the derivative of the inside function, which is what? What's the derivative of x squared plus 2x?
2x plus 2.
2x plus 2. There we go. This entire thing is the derivative of this 3-term question. And that's how you want to do it if you have 3 or more. If I had 4 things, then I would pair them up 2, 2, right? If I had 5 things, I'd pair them up 3, 2, something like that. And that's always going to be the case when you have multiple things together. And for the next thing, you plug x is equals -2 into this function, so you find f prime of -2, and that will give you your m value. So the question is find the equation, so you need to find m and b. Plug -2 in here, that'll give you the m. To find the b value, we've done this before. We have the x value -2. We need to find the y value. So to find the y value, you would find f of -2, not f prime of -2, but f of -2. You'd plug -2 in here. That'll give you the y value. You have the y, you have the m. Plug it in here like we did in the first question today to find the y-intercept for the final answer. All right, let's call it there. We'll pick it up tomorrow.
Okay, thank you.
See ya.